The binomial expansion, the binomial theorem, example 3. In the expression of x squared plus 4 over x all to the power of 12, find, in part A, the coefficient of x to the power of 6, and in part B, the constant term. So here, perhaps it is supposed that the binomial expansion has or had already been simplified, so that there are the combined powers of x. Okay, so let me now start, as one should usually start with such examples, with the r plus first term. This is r plus 1th term. Now, to use the expression for the r plus 1th term, you can write n choose r times a to the power of n minus r times b to the power of r. This is the formula. It's the general formula. And now what I'm going to do, I'm going to use it to express the general r plus 1th term, and then perhaps I will be able to find which term is the term which contains x to the power of 6, and this will enable me to find its coefficient. Okay, so what should I do now? I can rewrite the original expression x squared plus 4 over x to the power of 12. Now this is what we mean by a, and this is what is meant by b. We have a and b there, and in general the r plus 1 term is going to be, so n, well, it's known what n is. N is 12, so it's 12 choose r, like this, times x squared, which is a, all to the power of 12 minus r, because n is 12 and it's known, times b, which is 4 over x to the power of r, like that. Okay, so this is the term r plus 1, r plus first term, and now we can try to simplify it. This step of simplification is very necessary here. So I will leave 12 choose r without any change, and I can do something here. So here we have the power raised to the power, so you know that the exponents should be multiplied, so altogether this is x raised to the power 2 times 12 minus r, times, here I have 4 times x to the power of negative 1, all raised to the power of r. Okay, so again, let me copy 12 choose r, times x to the power of 2 times 12 is 24, minus 2r, times, and here I have the product which is raised to the power of r, so it is times, it's, well, actually let me write it a little bit smaller, times 4 to the power of r times x. Now I have x to the power of negative 1 to the power of r, which is x to the power of minus 1 times r, so it's x to the power of minus r. Now this can be simplified even further. Its numerical coefficient 12 choose r times 4 to the power of r times, and now this and this can be put together to make one single power of x, so it's x to the power, and since we have a product we have to add the exponents, so it's 24 minus 2r minus r. So this term in reality is 12 choose r times 4 to the power of r times x to the power of 24 minus 3r. This is the r plus 1 term. Okay, now this formula will be very essential, because now I can think about the coefficient of the term in the expansion which has only x to the power of 6. So you see, for different values of r, you have x to different powers, and I'm asking what r should I choose to get the power of 6. Okay, so let us ask this question. 24 minus 3r should be 6. I need the power of 6. So what r should I take? So you see 24 equals 6 plus 3r. I got it by adding 3r to both sides. I can subtract 6, so I can end up with 18 equals 3r. Now dividing by 3, I get r equal to 6. So r is 6, so it means that our term, which contains x to the power of 6, is the term t6 plus 1. So it's actually the 7th term. 6 plus 1 is 7, it's 7th term, and it is 12, choose 6, times 4 to the power of 6, times 4 to the power of 6, times x to the power, and you can see 24 minus 3 times 6, so 24 minus 18, and you see that it really is 6. So we have the proper term. And the question in the problem was find the coefficient of x to the power of 6. So what they ask is, what is the value of this coefficient here? 12, choose 6, times 4 to the 6. Now, I can use my calculator to evaluate 12, choose 6. So you use this special button, which is called NCR, and it gives me 924 times, and 4 to the power of 6, so again use the calculator, and it's 4096. So we can multiply these two numbers and get the answer that the coefficient is 3784704. So the 7th term of this expression, of this expansion, T7, is the term 3,784,704 times x to the power of 6. So this is the 7th term, and the answer to this part is this big number. Okay, now the problem has also the part B, in which we have to find the constant term. Now the obvious question is, if this is the general term, when do I get a constant term? It means the term without any variable, without the variable x. So there is the only variable here in this expression, it's the x. So when does it happen that x vanishes? Well, x will vanish, of course, when it's raised to the power of 0. So the question is, for what value of r do I get 0 as the exponent of x? So you see, r should be perhaps 8, because 3 times 8 is 24, so 24 minus 24 would be 0. So let me consider the term t8 plus 1, which is t sub 9. This is the 9th term for r equals 8, equal to 8, and this 9th term will be 12, choose 8, times 4 to the power of 9 to the power of 8, sorry, okay, because this should be r according to this, times x to the power of 24 minus 3 times 8 to the power of 0. Since this is 1, then my constant term is going to be this number. So this number is the constant term, and the constant term will have the value, so I can again use my calculator. So 12 choose 8 is the number 495 times, and 4 to the power of 8 is the number 65,536. So if you multiply these two, you get this times 495, and you get a big number, which is 32,440,320. So this would be the constant term. I could write it as follows: t sub 9 is 32,440,320 320, and this is the answer to part B of this exercise.